Hey, hello everyone. My name is Alan. I'm representing Evers, which is a subsidiary of KAYTUS. So today I'm gonna try to talk about the next step in AI technology adoption. And as one of the big OEMs in the world, we talk to a lot of customers directly every single day. And then we see a lot of customers having a lot of challenges on adapting AI as we speak, as one of the most the hot keyword of the industry today, right? So as you can see the chart right here, the CPU technology has been growing tremendous in the last couple years in terms of the power consumption, right? In the past, if you remember, like for a decade long, right, the highest TDP for a CPU is about 165 watt, and that's probably the maximum you'll ever see or design for a compute system. And right now, we're talking about 350 watt, and then as you can imagine, like the system power is going skyrocket, and then it's just off the chart. And then so we're talking about 1500 watt. So the density for server, right, per rack, right, in the past, you could possibly, right, with the 42U rack, you can possibly have like 30 system in a rack, right? Right now, with the power consumption limit, you might have to cut down to 20, 15, or even something less. So that's why the chart on the right hand side of yours, we're talking about the rack density, right? And in the past, we're talking about 2.4 kilowatt, 8 kilowatt, 16 kilowatt, and that's kind of the average what we're seeing some of the customers having right now, about 12 to 16 kilowatt in average. But we're projecting, right, in the future, we're talking about 34, and some of the customer that we have is even talking about 50 kilowatt or 100 kilowatt per rack. So as you can imagine, the power requirement for data center is increasing in a very tremendous amount of rate. And compound to that problem is the chat GPT, because everyone's been talking about AI for the last couple months, because OpenAI, right, with the chat GPT, tremendously, disrupt our industry of needing for compute, right? In the past, AI is a very niche application for many of the company, but as today, it seems like if your company, as a tech company, if you don't have offer any kind of AI services, you're kind of outdated. So everyone is buying AI server. And if you look at the chart again, right, we're talking about 800, 700 TDP per GPU, and that's just one of them. And as you know, right, the NVIDIA technology, the Intel technology, and AMD technology, each GPU box actually have 8 of this in a single box. So those kind of compounded to what the need for power consumption. So as an end user, what's your choice? The first choice is obviously build something new, right? Build a brand new infrastructure that can host that kind of power. And who really, oh, well, there's only, I believe there's only a handful of the customer out there really have that capex or capital to build every data center once a while. And then so seeking new infrastructure is great, well, but it's not for everyone. And obviously there's option for retrofitting the infrastructure that was designed, right, 10 years ago, 20 years ago, or built 10 years ago, 20 years ago, and then how do you retrofit that as part of the solution? I think at the expo floor, there's a lot of new companies, startups, who are thinking about how to add additional power to that. And since that's not my core competence, I'm not gonna spend too much time on it, but I think that's the only two options that you can do to really getting ahead of this power requirement. And we have seen a lot of customer, maybe one of you, right, sitting in the floor today, was trying to adopt AI, but you just don't have that infrastructure to actually adopt the AI system box that's existing out there today, right? So as an OEM, what can we do? Everyone talking about green, everyone's talking about how to make the system more efficient, and it's not even a possibility of making system more efficient and then by compounding all this computing requirement. Is it an option? So I want to give you an example. It wasn't like like everything we do, right? We're thinking about from this perspective. It's more better. It's more always the better, right? As an OEM, we want to compete with our peers, And then most of the time, we want to pack as many as components, as dense as possible into one single server, right? In the days like, I don't know how many years ago, right? Maybe before I was born. There's one U server, there's two U server. That's just one motherboard, and then two sockets, right? And that's it. And then with the revolution of all these servers, they start having more density, like 2U 4 node, like 3U 6 node, right? Or 3U 9 nodes, and things like that. It's raising like from every different OEM offerings. So we, as a company, technology, we want to pack more density into the server as much as we can. And then alongside the way, we added more storage, we added more PCIe card, we added more here and there. And then that's always one of the challenge. And then to actually have more to be a little bit differentiated compared to other OEMs. So I can see right here on the chart, on the very right-hand side, you have a very standard stuff like the 2U4 node. It was designed for something called a hyper-converged infrastructure, which means like you combine the compute, you combine the storage, you combine the networking into one system. That's a 2U4 node, right? In the past, the CPU power is only 165 watt. So it's thermally possible and physically possible to actually have that design and then still, able to air cool it. But as today, let's use an example, right? The 300 watt CPU, and then you have 24 drives in the front. Even though you might need to install all 24 drives, right? You might only need to have 8 drives. But because the requirement of the density, you have a backplane that's blocking the airflow from the cold aisle to the hot aisle with the opening ratio of only 16%, right? And what does that mean? Because your fan cannot push the air cool fast enough to actually into the system to take away the heat distributed by the CPU. So what you have to do is actually blow the fan at such high speed. And what does it do? Like it translates to, you will require about 500 watt for the fan to spin at the rate that you will desire for, and then to actually cool down the system. So take a look at the comparison on the middle and then left-hand side is the two new kind of concept that we have. Because when we're talking to the customer, when you are using this, right, do you necessary to actually have install 24 drive? Most of the cloud service providers that we talk to, they don't. They might use an M.2 as a device. They might use something like very small just for the operating system and garbage collection for the operating system drive, and that's it. So why do we, as an OEM, start designing things so complex, even though even though they don't use it, and then having this opening ratio only have 16% to actually to fulfill? Because we, right, as an OEM, we want to sell more general purpose stuff and then cover as much as possible. But I don't think that's the trend today, right? When you want to have one product cover everything, I don't think it's almost impossible to actually have that kind of concept and make it work. So if you look at the two in the middle and the right hand side, it's some of the stuff that we have done, right? So okay, you only need 8 drive out of the 24. Why don't I just give you 8 drive as a backplane? And then the rest of the stuff is opening for allow you to actually have the cold air through the system into the hot aisle. So that make your opening ratio from 16% to 53%. And that increase was able to actually help you reduce the fan speed, the fan power to a significantly lower to somewhere around 300 watt, which will save you about 200 watt bucks. That's pretty significant, right? And then as technology was evolving, and then everyone's talking about the new form factor, right? Like E1.S, E1.L, and things like that. And as you can see right here, E1.S is much smaller. It has the same capacity as a U.2. But the opening ratio increased dramatically from the 16 to 53 to 78, and that gives you another 100 watts also in terms of the saving. So I'm not saying hyperconverged is wrong. There's obviously enterprise customer was using hyperconverged in a way. But as a design OEMs, we should think about what does really customer was looking for in terms of the power saving, in terms of their application needs, right? So we will have variables like the one in the middle, like I said, and then one on the right, just for some sort of compute and grid application, right? We all have compute farms and grid farms. That's what's using for, for customers to log in and things like that. And then you distributed the rest of the workload to somewhere else. And then that's the thing that you will probably looking for. And you can maintain the same high CPU power out CPU TDP, and then still have the storage need that we're looking for. This is just one of the example, but it's one of the philosophy that Everest and KAYTUS kind of talk to the customer directly and then try to make sure we understand what you need and then what can we optimize for you. And then of course, when we talk about power saving, when you talk about fan power saving or system level power saving, you cannot not talk about liquid cooling, right? I think this is some of the data that's happening right here. And then I think if you walk the expo floor, you will see everyone, right? Everyone is showing some sort of derivative of the liquid cooling. And as you can imagine, like one of the biggest questions if you're coming from air cooling data center, you're asking yourself, what do I need to choose? Do I need to choose like direct to chip co-play, or do I do immersive? It seems like every one of them has a benefit. And then you come into a dilemma and saying, oh, I'm envisioning myself into the 10 years down the road, my roadmap for the data center infrastructure, what should I choose? Honestly, to you, I don't have the right choice, right? It has all kind of different benefit to every one of you, and then sometimes you just have to choose like the best fit your need. But as far as I can tell right now, the co-play solution seems like the easy, low-hanging fruit that everyone was able to adapt without dramatically changing your infrastructure, and then give you a little bit more lead time to think about what's right for you, right? And how do you do some sort of total liquid cooling in a way, right? We have seen technology was able to do direct-to-chip CPU, direct-to GPU, direct-to-chip like air cooling on a VR, and then Everest was trying to figure out, hey, can we do it on the NV switch, which is one of the component in the GPU system right now? Can we do it on a PCI card? Can we do it on an SSD as well? And then we do have solution and working on it, and then working with the customer directly on that. So as part of the concept is how can I cover as much as component as possible compared to what was presented here today, before today, and some of the solutions. And when even talking about just the direct-to-chip solution, there's so much proprietary stuff out there. Like it gets so confused comparing all these different datas, right? And then sometimes that's one of the reasons you couldn't decide it if you want to go liquid. And even though you know all the benefit behind it is what you were looking for. So jointly, Everest is working with Intel, and under the OCP subgroup, try to define some of the standard, such as how does this connector works, right? What's the measurement? And then how do you make sure you have a validating process to make sure all this process, all you purchase, is within the regulation, and then you can have a peace of mind when you're deploying this and not worry about what other possibility. And the full validation process is gonna be helpful, right? And not to you yourself, and then also help you to actually select the vendor that you were looking for. And then one of the things we do also believe is standardization. We're in OCP today, so standardization open does drive the cost down, right? With the massive adoption of everyone, I think the cost of direct-to-chip liquid cooling will be favorable, and then it will be not too much to add it on your capex. And I think that's important as well as one of the aspects. Everyone is really tight on the budget, and then everyone wanted more, but also with the limited budget. So I think that's really important. As for right now, for phase one, right? We have already contributed with the Intel, with the co-play as part of the Power One contribution to OCP. It's being completed. And then we are working on the rest of the connection system, cooling distribution, which is CDU, and monitoring system as part four. There's a timeline to that. So if you're interested in this particular project, which is a sub-project within OCP, and feel free to work in with us and then give us comments and feedbacks and some of the thought that you might have. And then I think the ultimate goal is actually, as a community, we can actually work together and figure this out, and then with a reasonable cost. And of course, last page I want to talk about is we're not just talking about specs and then making into a product, right? So we, Everest actually were able to actually take all this standard that we have been working with Intel and then the community with, and then make it into a product that we offer in our supply chain. So you can see the co-play is happening on all the server that we ship today. So it's one of the option, not just the compute server, and then also on the AI, and then also the CDU part of it. Even though it's part of the process to get it standardized, we feel like we are comfortable enough that the CDU that we're offering to the market today, it's belong to the standard and the validation process. And then of course, the rest of the cooling rack and centralized that's a code that we have at the very bottom. So I think overall, I want to talk to you about just the way that the challenge you might foresee, right, adopting AI, not just because how much do you need to understand how the AI frameworks works, but how do you deploy it in on-prem? On this, you go just, the cloud, AWS, Google. But as an enterprise customer, some of the data might have to be on-prem, and then those are the challenges you might foresee down the road by trying to buy a server, which is very powerful, but you just don't have that infrastructure to fit it into. So I'll be around here, and then our booth is just right across the hallway to the other side of the expo hall. So if you feel like you're interested in any of the conversation that we talk about, feel free to come by, and then we will have sales representative and sales engineer there to actually answer your question. Thank you.